Hi. So before any implementation of any data engineering project, there has to be an architecture that is followed. And these architectures, you don't just wake up and decide the architecture that you're going to use. Mostly, when you're dealing with database and data warehouse and in cloud, we don't just decide. There are certain principles that guide through this. Yeah, mostly some we might find them calling them data mesh principles, that are followed in every data architecture. Make sure that you watch this video till the end. My name is Simon Gogi, a data engineer, and I'll be taking you through this video. There have been several data architectures that have been in use for way long before till now, and when some when some of these data architectures have some drawbacks due to now we have big data, we have the volume, the variety of data. So there has to be a change and adaptation to this data architecture. And so we're going to look at them, the four of them. And so the first one is the relational data warehouse. So this is basically a data warehouse that is connected to a DB. And the other one is the data lake. So we have data that is loaded into a data lake. Data lake is a glorified file folder. It can store any file folder in any format. And in this case, we have an S3 for AWS, and we have Azure Blob Storage or ADLS Gen 2 for the Azure Cloud Service. So the other one is the modern data warehouse, and the modern data warehouse is the combination of the two previous ones that we have talked about. It's the combination of the data warehouse and the data lake. So it combines where you get data from a source and you load it to an S3 or ADLS Gen 2, and then you connect to a data warehouse. In this case, it might be Redshift or the Azure Synapse Analytics for the Azure. So it uses the combination of the two. And the other one is the data lakehouse. This is the most recent one that uses also a new file format, the data lake or the packet, and it works on compressing the data and not losing any data, but compressing the data and making use of the ACID properties. So it is not easy to delete data. It is to lose data. I would call it to lose data, and you can go back to any format that you had, any way that you had saved it. Very easy to revert to that. And so basically, this is where you connect a transformation layer on top of a data lake. So what you do this is you save on redundancy. So remember, in the modern data warehouse where we have the data lake and we have the data warehouse, we have this data is stored in two formats. It's stored in the data lake and it's stored in the data warehouse. So there is redundancy. You are using too much on saving on storing data that you don't need. So an example of this is where you get the data into S3 or ADLS Gen 2. And then on top of that, you add an EMR cluster for AWS or a Databricks for the Azure. And so you just transform the data, and then this data, you can return it back to you can save the file back to the S3 or the ADLS Gen 2. And then this data is ready for serving. So it's isn't this. And let's go through these data architectures in depth for now. And through this presentation I'll make, so let's understand them in depth. So we have the evolution of data architectures has been driven by the growing complexity of data, the need for scalability and advancement in technology. So let's go to the first one. We have the relational data warehousing, and was the first and widely adopted storage and processing systems for analytics, designed for structural data and highly organized. and it has schema on write format. And data was extracted from transactional systems, so LTP, this is just the normal database, and loaded into a warehouse. Yeah, so key characteristics, structured data, we have schema on write, we have it has ETL and optimized for SQL queries. Limitation, it's expensive to scale and maintain. Yeah, so let's say we have a database that is getting data from a source. Yeah, so it can be an app. Yeah, so if this, we have to make sure that this data is fast, so someone can make an order fast. And yeah, so the volume and the variety and the speed will come into factor in this. So it's very expensive to make sure that this is fast, and to scale it also in the data warehouse, very complicated. Yeah, and not suitable for unstructured data. For yeah, so remember you have schema on write, so JSON and images and logs cannot be stored here, and its rigid schema requirements make it difficult to adapt to changing needs. And the other one, we have the data lake. Data lake emerges a solution to handle the growing volume, variety, and velocity of data. So it's just an improvement on how to deal with big data, allowed organizations to store raw, unstructured, and semi-structured data. Yeah, and so in the cloud we have the S3, and in Azure we have the data lake. So key characteristics, you have schema on read, so data can be stored without a predefined schema. It's cost effective, so you can save large amounts of data, flexibility, and handle ETL. Yeah, and so some of the limitations we have, it's not easy to enhance data quality and consistency, and it's not optimized for performance and SQL queries. Yeah, so this is an issue that was encountered in the data lake, but this is a very good architecture. If you want to save on cost, make sure you need to change the how you save the data. Make sure that you change the data from CSV or any format to Parquet or data lake. Saves on cost and storage. Yeah, very effective. This third one is the modern data warehouse, and it evolved to address limitation of the data lakes and the traditional data warehouse. So it combined the scalability and flexibility of data lakes with the performance and structure of traditional warehouse, built on cloud native architecture. Yeah, and characteristics is the cloud native, so it's built on cloud, so supports semi-structured and can handle JSON, XML, and semi-structured format. Due to the data lake, it can handle these different file formats. Yeah, so separation of storage and compute, so there's separation of these roles, and it handles the ETL and the ELT, so it enabled for both. So if you can load the data and then transform it, and then you can extract the data and then load the data, yeah, and then transform it. That's for the ELT. So you can load the data and transform the data using DBT on the data warehouse, and then you can extract the data, transform it, and then load it. Yeah, so in this ETL, we extract the data, then we load it to a data lake, we transform it, maybe Databricks, and then you load it to a data warehouse, and it's optimized for SQL and analytics. High performance. So if you are using DBT, if you've ever used DBT on a cloud platform and you have big data, very fast. It's comparatively very fast, yeah, and seamless. Yeah, I would say that. So advantages is scalable and cost effective. So there's faster query performance and better support for diverse data types. Let's go to the last one, is the data lakehouse. So it's an emerged as a hybrid solution combining the features of data lakes and modern data warehouse, provides a unified platform for structured, semi-structured, and unstructured data while supporting both analytics and ML. So key characteristics, unified platforms, and then there's the ACID compliance. I just told you about that. So it ensures data consistency and reliability even for large scale data processing. So there's the schema enforcement and evolution. So supports this. So also there's support for diverse workloads. Then there's the open format. I just said this, where you can use the Parquet, Delta Lake, and an emerging technology that's the Apache Iceberg. Very, very crucial when you want to save storage on cloud. Yeah, so if you want to use cloud in a way that do not give you a headache, make sure it's cost efficient. And ways to ensure that it's cost efficient is ways like this. So advantages you have eliminates the need for separate data lakes and data warehouse. So you save the costs basically. Supports advanced analytics. If you're using Databricks and you're using Spark, SQL, or PySpark, then you know what I'm talking about. And provides a strong data governance and metadata management. So if you are creating a job where I'll talk of Databricks, that's the one that I'm conversant with. So if you're creating a job where you're transforming data in an ADLS Gen 2, supports this to the letter. So you're missing out. But yeah, again, simple every time. So if your industry is not able to get involved in this since it has so many costs, simple is always the best. Yeah, don't overcomplicate the data architectures. When you start merging, unless you are using the modern data warehouse, when you start merging data architectures, then it becomes unnecessary. There's some cloud services that at times I consider them unnecessary when you're looking to cut budget costs. Yeah, so you can look at them and really understand why are we using this architecture? What are the advantages that you are getting from this architecture? Security is not a feature for one architecture and a disadvantage for the other. When you have good data practices and when you have set good parameters, security is an advantage for all since you are using cloud. So yeah, depending on the data, depending on the requirements, choose the right architecture. Yeah, so that will be all for today. Till next time.